We are building the Hungry Traveling Snake project from the YBite Python curriculum available at www.ybite.in. In the previous video, we had a detailed discussion about how we select the threshold for determining if a snake head is, say, touching a food. Now we are going to move forward in this video, tackling the important problem where we want the food once it's eaten to become like the tail of the snake, which means that this food now must join the head and move along with the head so that it looks like a tail. Now this is an interesting exercise. We are going to do this in two steps. First, we'll look at just the first food, and then we'll see how the other foods come in. Let's see how we do it for one food. Now the key idea really is that I'm going to create a list. I've already done that here, called segments. Now the intention of this list segments is that it is going to contain all the foods that have been eaten. So which means that I start with an empty list. The moment a food is eaten, which is over here, I just go and say, look, segments dot say append that particular food. And how do I know what that particular food is? Well, that is just list of foods, say KK. Remember, this is running in a loop. If the food has not been eaten, then we check whether the distance is less than, say, a threshold, say in this case 20. We set eaten to true, and now I'm saying let us also append this to this list called segments. Let's visualize the list segment a little bit here. Remember, let's say we had 5 foods, so they were part of this list called list of foods. Snake eats food number 2. Food number 2 becomes part of segments because we are appending. Now the important point here is that there is no specific order in which snake might eat food, in which case these foods may end up being whatever, but they actually look identical. So it doesn't really matter. So the order here may not follow, but we are now going to deal with this list called segments. Now let's start this one by one. So let's say we have only the first food eaten, which is, say, only on the segment 0. Now really all we want to do is that somehow put it right behind the snake. Now here I'm taking steps of 10. So I just want to make sure that my snake head food position is always just behind the snake head. Now the way I would do it here is quite interesting. I will in fact move it to the same position as the snake head. We'll see that later. The reason that works is because snake head would move momentarily. There's an overlap, all right, but the snake head would immediately move away, and that will create that animation. So what's going to happen is that I am, like I said, once the food is eaten, I momentarily go and put this on the same position as the snake head. Since the snake head moves away, it creates this animation that the whole thing is moving away, and of course this happens after, say, 0.1 seconds. Now let's see how we do this in code. We will just check for ourselves if the length of segments is 0, if the length of segments is, say, more than 0. Like I said, I'm going to figure out where is my head position, say X and Y position of that head, and I'm going to move this segment 0 to this X and Y. Now this is really quite interesting and something that requires thinking. Like I said, there is a momentary overlap being created, but after that the head is moved away, which means that this must happen inside the while loop, all right, but this must happen before the snake head is moved. So that's why this momentary overlap is created. Now let's do this in code and see this working. So I come in here and I say, look, outside the for loop, I just ask myself a question. If, let's say, length of segments is, say, greater than 0. Now I need to put this check, because if I did not put this check, then if the segment list is empty, then I will get an error right away, index out of range, because the list is actually empty to start with. But if a food has been eaten, it means that the segment list is now populated. We'll just say for, say, segment 0. Now what I'm going to do is to find out where the head is right now. So I say t dot, say, x core. The x position, the y position is, say, t dot, say, y core, and I'm just going to say, look, let us move the segment over there, right? So I'm just going to say segment, say 0 dot go to, and I'm going to send it to, say, x and y. Now really this is where the head is, but like I said, momentary overlap, all right, so this has to be segments, otherwise it's going to be a problem. So segments, momentary overlap, all right, but then the head moves away, and that's how the code keeps running. Very interesting. Let's see this working. So now when I play this game, let's say I go and eat food. Notice I ate this food, and now this guy is moving along with the head. Now right now we have done the code only for the first food, and that's why only the first one is moved. At this point, I want to make an interesting comparison here. Let's say we had built a regular snake game where we had a fruit that would move to a, so where we had a fruit which the snake eats and the tail becomes longer, which is what we had done, for example, in Scratch. The fruit itself will move to a random position. In fact, the logic would remain exactly the same. The only difference is that instead of using the fruit itself as a tail, we will create a new turtle to become the tail. In fact, what we will do, and that's what is done in many implementations, you create a new turtle, append it to the list segments. Everything else, in fact, remains exactly the same. Right now, it's only for one, one tail. Later on, the same idea will apply to multiple tails, but we'll see that in a separate video. I hope you found this interesting. In general, if you think creating activities, learning by doing is your way of learning, look at our website because we have many, many, many such activities. Take care. Thank you so much. Bye bye.